Hello everyone, now we are going to perform the analysis of a step bar on mechanical Apdl. So here we go. So we click on preferences, structural, OK, preprocessor, element type, add or edit or delete, add, link, OK, close. Then we will define the material properties. Then we go on to material models. Material model number 1, structural, linear, elastic, isotropic. Here we will define the Young's modulus. Ex is for Young's modulus and Prxy is for Poisson's ratio. Young's modulus for aluminium is given as 70 gigapascals. For steel it is 200 gigapascal, and for bronze it is 83 gigapascal. So in order to convert, as the unit of this software is in mm, so we have to convert gigapascal into Newton per mm square. So 70 gigapascal will be 70 e raised to 3 Newton per mm square. It is 70 into 10 raised to 3 Newton per mm square or megapascal. You click on OK. As we haven't defined the Poisson ratio, so the system will automatically set it as 0. Material models, new models. We will do this for defining the property of second section of the step bar, that is made up of steel, and Young's modulus of steel was 200 GPa, so we will convert it into Newton per mm square, so it will be 200 into e raised to 3. We click on OK. Then for third section we will again click on material, new model, 3 ID, and isotropic. And for bronze the Young's modulus was 83 gigapascal, so it will be 83 e raised to 3 Newton per mm square. Click on OK. As all the material properties are defined, then we will go to sections. Here we will select link, add first section, that is of aluminium, and so here we will type aluminium, and the cross sectional area of aluminium was 900 mm square, and for steel it is 2000, and for bronze it is 1200. So we will define all the section in sequence for our convenience, and in order to define it easily. So first aluminium will be of 900 mm square. Click on apply. Similarly the second section, so type here 2, steel 2000 mm square, apply. And third section bronze, okay, bronze, cross sectional area 1200, okay. In order to see whether we have defined the cross sectional area correctly, so we can see in edit we can even edit their values. So click on aluminium, okay, 900, yes it is correct. Similarly for steel, and similarly we can look for bronze. After that we are going to go for creating model of the step by. Then first we have to define the key points. Here we will select modeling, create key points in active cross CS. First if we don't type a number of key points, it will automatically select in the sequence in which we define the key points. So first key point is at origin, say for 000, and if we don't define any value in any box, it will automatically consider it as 0. So we will click on apply. Second is at 500 mm, so we will type here 500 mm. Apply. Third is at 200, it's sorry 250 mm, so 500 plus 250 is 750. and third is at 350. So 500 plus 250 plus 350 is equal to 1100. So here, so the sequence of defining key points is 500 is defined, so next one is 750, and the last one is 1100. Always keep in mind that at the time of defining the last key point, always click on OK. If we click on apply then on OK, then two key points will be mounted there. So always click on OK at the time of defining the last key point. After that, we will go to lines. We'll select line, straight line, select the key points. Automatically the line will be drawn in sequence, and see that you are clicking on the consecutive or corresponding key point so that it cannot overlap each other. Click on OK. After that, we will go to meshing. Here we will define the properties of each section. So for first section, defining the property of first section, we will click on pick lines, select the line. OK. Material number 1, as section number 1 is of aluminium, so we will select aluminium, then click on apply. Similarly for second section, click on the 2, steel 2, second section, as second section is of steel. We will do similarly for third section, that is of bronze. Click on OK. So the material properties and their material properties are defined on in section. After that, we will go to size control, manual size, lines. As the meshing of all lines are same, so we will directly click on all lines. Otherwise, if different meshing is to be done, so we'll select pick lines and select each separate lines and define its meshing. So here all the line meshing are same, so I will click on all lines, and the element should division, and on in number of element division we should always click on 1. This is same for define while doing the analysis of a truss and step bar. Always type number of element division as 1. Always keep in mind. Okay, then we will mesh lines, pick all. The meshing is done. After that, we will define loads, apply structural displacement on key points. As at left corner and right corner, the step bar is fixed, so the DOF of the corners will be is equal to 0. Therefore, we will select the corner key points and click on OK. RDF 0. Here we will type 0, or if we don't type anything, if we don't type anything, automatically it will say type as 0. Then we will click on OK. So we can see here the key points are fixed completely. After that, we will define the loads. Here we will select force or moment, and then on key points, select the key points. In the configuration diagram, we can see that the load applied on here, load applied here is 50 Newton, and also here it is 50 Newton. So the loads are same, so we will select both key points, that is of at the distance, that is first key point which is at the distance of 500, and the second, sorry, third key point which is at the second key point which is at the distance of 500, and the third key point which is at the distance of 750. Click on the fix. As the loads are in x direction and x and in negative direction, so we will define the load in negative value, so it is 50. Click on OK. As we here the arrows are displayed, this which means that the load is applied on the key points and the arrow is going in the negative direction of x. After that, as the complete configuration defining is completed, as so we will directly finding go for finding the solution. Yeah, so we will click on solution, solve current ls. So solution, all solutions are formed. In order to define what we want, we will go here. We have to see the displacement, stasis and reactions. So in order to see the deformation, here we will go to general post processes, plot result, deform shape. We will select deform on deform, click on OK. As we can see here anything, we cannot see here anything or any deformation. So in order to see it, we will click on plot controls, style, side and shape. Display of element will be ticked on, click on OK. So here we can see the deformation. This point has moved here, and this from this point from here. So as you can see here, the deformation. Similarly, we can see the maximum deformation by clicking on nodal solution, that is contour plot, nodal solution, UF solution, displacement vector sum, and click on OK. Here we get the value of maximum deformation. Blue means fixed and red means maximum deformation. Second, we have to see the stresses. So we will go to list result. Second, we have to see that how much displacement has had happened at each node. So we will go for list result, nodal solution, DF solution, vector sum, displacement vector sum, click on OK. So we will get the value of displacement at each node. After that, we will have to see the reactions at support. So we will go to reaction solution, all items, OK. So we will get the value of reaction. So as the load applied is 100 Newton, so minus 100 Newton, that is P1 P1 plus P2, and all the loads are in negative direction. So reactions are in positive direction, that is of at 1 it is 31, and at fourth node, that is here it is 68. After that, we will see the stresses in each element. For that, we have to define element table, define table, add by sequence number ls, and type here 1. Click on OK. As you can see, the value here, the value is 1. Click on close. Then go to list result, element table data, and let's select ls1. Click on OK. So we will get the values of stresses in each element. So here are 3 elements. So we will get the three values of stresses. Here it is the minimum value of stress, and here it is the maximum value of stress. Hence, the analysis of step bar is completed. In order to click the image, we will go to plot controls, hard copy to file, color, JPG. As image is, we have to select the format of image that should be in. So we will select JPG. As the background is black, so it is not visible clearly, so we will select reverse video, due to which the black background will be converted into white. After that, orientation with landscape, and click on OK. Hence the analysis of step bar is completed.